What's the difference between Arduino and Raspberry Pi? Both are popular devices to kickstart your engineering project, but they serve different purposes. Arduino is an open-source electronics platform based on easy-to-use hardware and software. Raspberry Pi is more of a mini-computer. It can run an operating system and handle complex tasks. The Uno R4 Wi-Fi features the RA4M1 microprocessor and the ESP32S3 with built-in Wi-Fi and Bluetooth. It has multiple I/O pins for analog and digital signals, as well as PWM outputs. This makes it ideal for tasks like controlling motors, reading sensors, or dimming LEDs. Raspberry Pi is built using the RP1 I/O controller and features a Broadcom 2.4 GHz quad, Core 64-bit ARM Cortex CPU. It includes USB 3.0 for fast data transfer and Ethernet for networking. The GPIO pins support digital signals and PWM. Plus, with PCI Express, you can add AI accelerator cards for even more power. Arduino uses the Arduino IDE and programs in C and C++. Raspberry Pi runs a full operating system, and you can code in multiple languages. Everything has its advantages. It all depends on what you need for your project. I always thought that low temperature sweat absorption is to use very low temperature to weld. In fact, it is true. Of course, this temperature is compared with high temperature sweat absorption. Its solder is generally a tin wall alloy with a melting point of about 140 degrees Celsius, while high temperature sweat absorption solder is a tin silver copper alloy with a melting point of at least 220 degrees. Depending on the formula, the melting point can be even higher. The advantage of low temperature sweat absorption is that the operation temperature is low. Sometimes you don't even need to use a soldering iron. Just add some heat to the sweat material and you can easily get it done. The requirements for equipment and technology are relatively low. It is also convenient to operate, especially for some materials or electronic components that are more sensitive to temperature. Low temperature welding can better protect their performance and integrity. As for the disadvantages, I believe everyone has heard that the B element in the solder is a brittle material. Due to its low melting point, it is not as strong as high temperature welding. Especially in the case of long-term mechanical stress, the welding point may fall off or break, and the welding point is not so bright, which affects the appearance quality of the product to a certain extent. In fact, both low temperature and high temperature suction soldering belong to lead soldering, which is to make the lead material into a liquid like water, but not to melt the object to be soldered. After the lead material becomes liquid, it combines with the parts to be soldered and becomes hard after cooling down, so that the two objects are firmly bonded together. When using a soldering iron to solder, you will find that the two seem to be incompatible. If you add some rosin, it will be different. Once the rosin is heated, it will melt, allowing them to hug each other tightly. This rosin is actually a flux. It acts like a cleaner before welding. Think about it. If the metal is left outside for a long time, oxides will grow on the surface. It is a small obstacle during welding, which can prevent the combination of metal and solder. At this time, rosin comes in handy. It is weakly acidic, which will wash away the oxides and make the metal surface clean. In this way, the metal and solder can stick together tightly. This rosin is just a type of flux. Moreover, many Hunksy wires are hollow now. Hun flux is filled inside. No need to add Hun flux separately. Like and follow for more informative videos. The stepper motor converts electrical energy into precise mechanical motion. By supplying it with DC electricity in a specific sequence, it can rotate continuously in either direction or in controlled small steps, allowing for accurate, high-precision movement. The motor can even stop at a desired point and hold this position. This is more advanced than a standard DC motor, which can only rotate continuously in either the forwards or reverse direction. Therefore, stepper motors are far more useful in automation and manufacturing because they offer precision control. The stepper motor consists of a rotor that is generally a permanent magnet, and it is surrounded by the windings of the stator. As we activate the windings step by step in a particular order and let current flow through them, they will magnetize the stator and make electromagnetic poles, respectively, that will cause propulsion to the motor. So that's the basic working principle of a stepper motor. That is why we find stepper motors used everywhere, from 3D printers, CNC machines, printer scanners. Hope you understand it. Differentiating between a motor's start capacitor and run capacitor can be challenging for many people. If your motor only has one capacitor, it is definitely the start capacitor, which is denoted by the letter CD. If your motor has two capacitors, those starting with CBB are run capacitors. Another method of distinguishing them is by comparing the capacitors on the same motor. The one with the larger capacitance is the start capacitor, while the one with the smaller run capacitor. Typically, the capacitance of the start capacitor is 5 to 7 times that of the run capacitor. This is a diode. It is a semiconductor device with two terminals. The diode has a very important role in electronics. A diode is like a one-way valve for electricity. It allows the flow of current in one direction and blocks the flow of current in opposite direction. To construct a diode, a single piece of pure semiconductor is half doped with trivalent impurities and another half is doped with pentavalent impurities. Due to this, half of the material become an N-type semiconductor and another half become a P-type semiconductor. At the atomic level of diode, free electrons from N side migrate to fill the holes of P side, which creates a potential barrier in diode. A diode only allows the flow of current in its forward biasing. Hope you understand it. This tiny component is used in almost every electronic device you can think of. It comes in different sizes and ratings, usually ranging from just a millimeter to a few centimeters. What is it? It's a capacitor. A capacitor is designed to store electrical charge. It has two metallic plates separated by an insulating material called a dielectric. When voltage is applied, these plates hold an electric charge. Often, the plates are rolled up into a cylinder to save space. A capacitor stores electric charge. It's a little bit like a battery, except it stores energy in a different way. It can't store as much energy as a battery, although it can charge and release its energy much faster. I want you to imagine water flowing through a pipe. The water stops when we shut the valve. Then we have a reserve. So now, when the valve shuts, we still get a flow of water out of the pipe for a short duration. This is what the capacitor is doing. It stores electrons and then releases them when they are needed. But capacitors have a maximum voltage and some are polarized. So if we exceed this, they will burst. We all know that a capacitor allows AC but blocks DC. Let's see the reason behind this. If we connect a capacitor to a DC power supply, it will begin to charge. Because of this, there will be a current flow in the circuit. But once the capacitor is fully charged, there will be no DC power supply, space for the charges, and there will be no current flow. When we connect this charge capacitor to a load, the capacitor will begin to discharge. During this process, there will be a current flow. So we can conclude that there is current flow in the circuit whenever the capacitor is charging and discharging. So this is why capacitor blocks DC. It actually has some current flow initially, but once capacitor is fully charged, it can no longer allow any current flow in the circuit. Let's see the case of AC. Let us consider an AC power source. For our convenience, let us divide this waveform into 4 parts. In this first part, the voltage rises from 0 to its maximum value. During this process, the capacitor will begin to charge from 0 to its maximum value. And in the second part, the voltage drops from maximum to its minimum value. And during this process, the capacitor will begin to discharge the stored charges. So there is a continuous charging and discharging happening in there. Let's get to the third part. In this part also, the capacitor will begin to charge from 0 to its maximum value, but in the opposite direction. And again, these stored charges will be released. So with an AC power supply, a capacitor constantly charges and discharges. And because of this, there is a constant oscillation of charges between its plates. So a capacitor with an AC power supply will have charges oscillating between its plates. And this constitutes a current flow. This is a resistor. We use them to protect things like LEDs. And that's because a battery pushes a lot of electrons around a circuit. When we add a resistor, less electrons can flow around this circuit. The electrons collide with atoms inside the resistor, and these collisions generate heat. Inside the resistor is a carbon film layer. Electrons can flow through this just fine, but we cut a helical groove into this, and this creates a narrow path. And that makes it very hard for electrons to flow through without colliding. The longer the cut, the harder the path becomes for an electron to flow through. And so, the resistance increases. We calculate the voltage drop required and also how much energy the resistor needs to remove from the circuit. And then we select the appropriate size resistor. Otherwise, it can burst into flames. You've probably noticed this device on plenty of circuit boards. It's a transformer, a critical component in any electrical system. Transformers come in all sizes, from as small as a microchip to as large as an entire room, highlighting their versatility and significance in electrical systems. It is used for increasing or decreasing the voltage levels of an AC supply. A transformer consists of primary and secondary coils wrapped around a ferromagnetic core. When the primary coil is fed with an AC supply, it produces an alternating magnetic field. This alternating magnetic field also links with the secondary coil, which produces an EMF in the secondary coil because of electromagnetic induction. The output voltage can be modified by changing the number of turns in the primary and secondary coils. I hope that you get the idea. This is a diode. It is a semiconductor device with two terminals. The diode has a very important role in electronics. A diode is like a one-way valve for electricity. It allows the flow of current in one direction and blocks the flow of current in opposite direction. To construct a diode, a single piece of pure semiconductor is half doped with trivalent impurities and another half is doped with pentavalent impurities. Due to this, half of the material become an N-type semiconductor and another half become a P-type semiconductor. At the atomic level of diode, free electrons from N side migrate to fill the holes of P side, which creates a potential barrier in diode. A diode only allows the flow of current in its forward biasing. Hope you understand it. Explore the different types of mechanical joints that power motion and precision in engineering. A gear joint is a mechanical connection that uniquely ensures precise motion and torque transmission with constant velocity ratios between shafts. A cam joint is a mechanical connection where a cam profile converts rotational motion into controlled linear or oscillatory motion of a follower. A knuckle joint is a mechanical connection that allows angular motion between two parts, typically used to transmit force in tension or compression. A pin-in-slot joint is a mechanical connection where a pin slides within a slot, allowing limited linear motion while maintaining rotational freedom. A universal joint is a mechanical coupling that transmits rotary motion between two shafts at variable, non-parallel angles. A rod-end ball joint is a mechanical connection that permits multi-directional rotational movement, commonly used to link rods or shafts with angular misalignment. A screw joint is a mechanical connection that uses a threaded fastener to join two or more components by converting rotational motion into linear force. A prismatic joint is a mechanical connection that permits linear motion along one axis while preventing rotational movement in all directions. Did you know that Arduino has a Pro series? Meet two powerful products from this lineup, the Arduino Opta Wi-Fi and the Portenta machine control. Unlike the popular Arduino boards we all know and love, the Pro series is specifically designed for industrial applications. First up, the Opta Wi-Fi. It's a secure and easy to use micro PLC with industrial IoT capabilities. The Opta Wi-Fi features field bus integration using Modbus TCP over Ethernet and Modbus RTU over serial RS485. It also features 8 configurable analog and digital inputs, along with 4 relay outputs. Next, we have the Portenta machine control, based on the Portenta H7 and powered by the STM32H747 SHI. It supports CAN and RS485 protocols for communication, and with its industrial-grade I/O, it can interface with a wide variety of sensors and actuators. Both products can be used in various ways. Hope you understand it. Not sure which motor to use for your project? Let's break down the key differences between DC, stepper, and servo motors. DC motors are your go-to for simple tasks that need speed, such as fans or cars. They spin continuously and smoothly when you apply voltage. If you need precise control, stepper motors would be a more suitable choice. A stepper motor rotates in fixed steps, making it perfect for 3D printers. You can tell it exactly how far to move. Servo motor give you the best of both worlds, speed and precise control. They use feedback to move to a specific angle, which makes them ideal for robotic arms. For tasks needing minimal speed and accuracy, a stepper motor is ideal, but for high-demand applications, a servo motor's higher cost is justified by its superior performance, despite its susceptibility to overload damage. Choosing the right motor depends on your application. Which one do you think best fits your next project? This is a transistor. It's an electronic component which acts like a switch. It blocks the flow of current in a circuit until we send a signal to the control pin. The signal can come from a manual switch, another circuit, a sensor, a solar panel, anything we like. We just need to provide enough voltage and current to activate the transistor. So I want you to imagine water flowing through a pipe. Then we block the flow with a disc. The disc is attached to a swing gate in another smaller pipe. The further the swing gate opens, the more the water can flow. The swing gate is very heavy though, so a small amount of water won't open the swing gate. At a certain point, enough water is pushing against the gate, and so it opens. That's what the transistor is doing. When we provide enough voltage and current to the control pin, it allows electricity to flow in the main circuit, but if we provide too much, it can burst into flames.